Meron na naman tayong bagong project. Ay, ano na naman bagayaan? Ito, bagong project. Meron tayong capacitor, switch, mga resistor, ceramic capacitor, transistor, mga discrete components. At may speaker. Speaker 8 ohms, 0.5 watt. Ay, ano naman ng ano niyan? Aba ba? Lagyan natin ng supply para malaman mo kung ano ito. Nine volts battery. Pindutin. Uy, bakit ayaw? Ba? Aba, ano nangyari? Teka, bakit ganun? Yun! Diba? Oh, isa pa. Ayun, oh. Eh, ano yan? Ano yan? Oh, pakinggan mo. Pag pinindot ko, parang huni ng palakayan. Hindi yan palaka, ibon yan. Yan ay bird sounds using transistor. Oh, sapa. Uy, wala na naman. Yan ang bago nating project, Bird Sound. We have now the figure 1, schematic diagram of our bird sounds using transistor. So we're using 2 transistor. BC557 PNP type, BC547 NPN type. They are complementary or connected this way, the 2 transistor. The output is the speaker, 8 ohms, 0.5 watts. And we have these 2 resistor, serve as the biasing resistor to the transistor. So this 2 transistor serves as a switch. And then we have the power supply of 9 volts. Into the input, into the power supply, we have this power indicator. So that we know that the circuit is on, and we have the switch. This is a normally open push button switch. We have decoupling capacitor or coupling capacitor, decoupling capacitor for voltage stabilization of the circuit. Going to the right side, we have this 1K resistor connected to the capacitor, feeding back to the output. Also for 70 ohms resistor with a capacitor of 220 microfarad, 25 volts to the ground in series with this resistor. Initial state of the circuit, only the power LED turns on because there is a current that flows from the supply 9 volts to the current limiting resistor, then to the LED, turning this LED on. So we have this power indicator LED, it is on, but this whole circuit is not on, it is off because the switch is open. Why is it that we produce a bird sound using this circuit? Why? It is due to the configuration of the two transistors with the help of the capacitor. It is an oscillator. Okay, continuously oscillating. Why? Because when we press the switch, current flows into the decoupling capacitor, 1000 microfarad, 16 volts. It has a higher value because it serves as a supply to the whole circuit once we release the switch. So it initially charging the capacitor and then discharging to the circuit. What happened now to this transistor? It is open because there is no current that flow into the collector emitter of the second transistor. We need the current to flow from base to collector to emitter to the ground of the second transistor. Why is it open? Because the current flows initially from R1, R3, then to the 104 or 0.1 microfarad capacitor, then feeding it to the positive side of the speaker, then to the ground. Also, the capacitor is charging through this way. Another capacitor is charging from VCC, R1, R3, R4, then to the capacitor, and then to the ground. Two capacitors, they are charging. So it bypasses these two transistors. And once the capacitor now is discharging, it discharges through the base of this first second transistor. It will now turn on because of there is a current that flows from emitter to the base. That is the current flow in the PNP type transistor. Current flows from emitter to base, then to the collector to the emitter, switching this transistor on. There is now a voltage across the base to emitter due to the discharging of the capacitor. Two capacitor is discharging to this transistor. These two capacitor is discharging to the base of the second capacitor transistor, causing the current to flow from emitter to the collector and then turning this speaker. But initially, when we charge the capacitor, the output is on. There is an output. Like this, there is an output, and from the discharging, we have a voltage spike due to the discharging of the two capacitor. Charge first, then discharging, charge, discharge, charge, discharge. These two capacitor are in a on, then off, on, off, on, off, on, off, on, off, on, off. We can see that in the oscilloscope, the characteristic or the properties or the nature of the waveform produced when I connect, when we are going to connect the oscilloscope from positive to the negative of the speaker. So we're going to connect the oscilloscope from positive to the negative or ground of the speaker, so that we will know the nature of this waveform that is produced by this circuit. Let us now test the circuit. When I press the switch, okay, we can change the scale. That is the waveform produced by the circuit. And if we're going to change the scale again, and we capture the screenshot of the waveform. So you can see here, let's make a big we have voltage division of 20 volts, 20 volts, 1 square 20 volts, or let's make it if we're going to make it a 10 volts per division, that is the waveform. Okay, and we cannot see the voltage spike, the negative voltage produced by the circuit. We have the positive voltage. It means when the capacitor is charging, it has an output, and this one is the discharging characteristic of the capacitor. The negative voltage, which is around negative 35.94 volts produced by the circuit. A negative voltage spike produced, and then this is the positive voltage produced by the circuit. So here we can see there is a voltage spike produced by the circuit into the negative region of the or the discharging of the capacitor, this one. And we have this BRMS 2.3, which is it has a frequency of 2.595 kilohertz. So the circuit, the bird sounds, is it has it is composed of a series of voltage spike into the negative region of the waveform. That's why it sounds like a bird. A voltage spike, negative 35.94 volts, and a maximum voltage of 7.8 volts. So this one 7.8 volts during the time that the circuit capacitor is charging and the discharging. So that is the effect of charging and discharging of capacitor. And it continuously You can hear the sound as long as there is a power. In our circuit, we have this bulky capacitor. That is the one supplying the voltage now to the whole circuit. Once there is no charge for this 1000 microfarad capacitor, the sound stop. You cannot hear now. You cannot hear the sound because there is no charge. There is no more. There is no charge inside this capacitor. So we can, when we press it, that is the high frequency this one is the high frequency we can hear this high frequency. It's 2.15 kilohertz. So that is the waveform characteristic of the Bird's sound circuit using the transistor. It is due to the charging and discharging of capacitor.